Hello everyone, welcome to another part of our Farming RPG tutorial series. In our last part, we managed to set up the inventory equipping system. You can switch things out and remove them. And we also made this little status bar at the bottom left hand side of the screen. And we have managed to display whatever is equipped on the left side. But today we'll be setting up the time system. So we'll cover the date and the time. So first things first, let's go to our scripts folder and create a new folder called time. And we'll create a new script. We'll call this game timestamp. This will be the class that will manage the time and date system for us. It's not going to be a monobehavior class, so we'll take that out. First, we'll make variables for each of the components that we want in our time system. And we'll create a new enum for seasons. Now in this timestamp, we need a constructor since we're not going to be using monobehavior. We'll take in the parameters necessary to build the class in the constructor and then assign it accordingly. Because our local variables and the parameters share the same name, we have to use the this keyword to refer to our local variables. So I forgot to declare the day. Now that we have this instance, we have to figure out how to update this timestamp. This timestamp will be set up in a manager class in which we'll increase this by the minute. So we'll create another function, call this update clock. In update clock, the minutes will be increased. There are 60 minutes in an hour, so at the 60-minute mark, we will convert it into an hour. There are 24 hours in a day, so at the 24-hour mark, we'll convert it into a day. Now, our dating system is a lot simplified, so instead of 12 months, we'll be having 4 months in the form of seasons. So after spring comes summer, after summer comes fall, and after fall comes winter. And in each of these seasons, we'll have 30 days. So when the day exceeds 30, now the thing about dates is that they don't start from 0, so they are going to start from 1. And we'll update the season to the next season. But as you can see in the enum, after winter, it should reset back to spring. So let's change this. Now, how is it that we are able to just increase the season by one number? Isn't this an enum? Well, you see, this enum can also be represented by an integer, so you can cast it into either seasons or numbers. Right, so spring represents 0, summer 1, fall 2, winter 3. So this is why we can normally just increase this by 1. But we can't do this for winter because winter is the final value in this enum set. So we have to manually reset this to spring and increase the year here. Now that we've set this up, let's create a way for us to convert each of these back into whatever was here, because we'll have to convert things a lot in future. So we'll be making it a static function so that it can easily convert from any context. So we're gonna convert the hours back to minutes, days back to hour, and so on. To convert seasons to days is a bit more different from the others. Each of our enum values has a corresponding integer. So what we can do is we can cast it why is it that we can just multiply the integer of our enum by the days? Because the year starts from 0. So in our first season, whatever the value of the day is the season, right? 30 days haven't passed yet. But by the time we reach summer, 30 days from spring has already passed. So it's 1 times 30. Likewise, fall, 2 sets of seasons have already passed. So it's 2 times 30 and so on for winter as well. If we were to look at our UI, we also want to display the day of the week. Now, how do we figure out what the day of the week is? Well, it really depends actually. Because how it works is that we first have to get the starting day. So whether we want to start from Sunday, the first day start from Sunday, or we want it to start from Monday, we first have to decide which is which. If you were to look at a calendar in real life, you would see that on all the dates that fall on a certain day, if you were to divide it by 7, they'll have the same remainder. So like in the case of December 2019, if you divide 1 by 7, you have a remainder of 1, 8 will have a remainder of 1, 15 will have a remainder of 1, and so on. Likewise, Monday is going to have, this whole area is going to have a remainder of 2, and so on and so forth. We can do the same thing here. We have to declare another enum. So let's make a function to get the day of the week. In any given year, we just have to know the value of the day and divide it by 7, and then get the remainder. We'll be using the modulo operator. So first, you have to get the number of days that passed. We first have to get the day. We have to get the season, the year. Right. Oh, that's right. We forgot. Years to days. We get the years, and then the seasons, and then the days, and the day index. When we divide this by 7, we want to get the remainder of it. So days passed modulo 7, and then return. Remember, enums are a set of constants with a value behind them. So in this case, we can cast from integer to enum or enum to integer. They work both ways. So we just have to cast the day index back into our day of the week enum. So with our current setup, day 1 would actually be on Monday because the remainder from here will be 1. Because 1 will start here, the remainder will be here, and Monday's value is 1. If we want our day to be Sunday, we have to set this to 0. Right? Saturday has to be our 0 value if you want the calendar to look like this. Because if you see from December 2019, 7, you see all the dates here leave a remainder of 0. They're all divisible by 7. Now that we have our timestamps more or less settled down, let's go on to create the time manager. Create a script called time manager. Open it up. Let's go to inventory manager. Same thing, we have to take this singleton behavior and declare an instance. And we need a timestamp. Now by putting serialized field, we are able to put it in the inspector. So let's go to the inspector, drag time manager on here. Whoops. Yeah. Now, even though this is supposed to be shown in the inspector, our timestamp isn't getting shown here. Why is this the case? Because this class is not serializable. So we have to add this system.serializable. Now we should be able to see it displayed in the inspector like that. But let's keep this private and initialize our timestamp here. Now, when we create a new instance of a timestamp, we have to follow the parameters as dictated by our constructor. So the year we'll start from year 0, and we're gonna start with spring, and the day will be 1, of course. The hour shall be 6 a.m. We want the play to start at 6 a.m. and the minutes at 0. So now if we were to play the game, now you see it's exactly as it is. So year 0, spring, day 1, 6 a.m. But we want this time to move. We can't just have it stationary like that. So let's have a, I don't think we need the update function. We don't want this to be called every frame either. So for this game, we'll have 1 second to be 1 minute. That's going to be the game scale. So first we need a function that updates it. So it won't be called every frame, but we want it to be called every second. And every time it ticks, the clock ticks, it's going to update its clock, right? Remember, we defined this function. This increments the time by 1 minute and does this. To call this function every second, we just have to create a coroutine. So we want to wait for seconds, whatever the time scale is, before we tick. And this is going to be in a while loop. It's going to be constantly repeating. Now the time scale, let's create a variable to control it. So it's going to be every 1 second. And don't forget to call this coroutine in the start. Now when we test it, see that the minutes are increasing by every second. If you set the time scale to 2, it's gonna go much faster. If we go it to 0.5, it's much slower. So the time scale should be 1 for now. Now that we have a basic time system working, let's get it to have a day and night cycle. So we have our light here. So we're going to rotate its X position, its X rotation, to give it the impression that the sun is moving, right? So this is day, this is night, right? So how do we do that? So we know that the sun is going to revolve 360 degrees, right? It's going to move around our world in 360 degrees in 24 hours. So the sun moves 360 degrees in a day. Having 24 hours in a day, the sun moves 15 degrees in an hour. And since we want the sun to update as we update this time, it's going to move by the minute. 15 over 60 because there's 60 minutes in an hour. and that is 0.25. Now, a day has about 4 phases. This is noon, this is midnight, this is sunrise, and sunset. So, at noon, the sun will be here, right? And that is 90 degrees. So that means at midnight, when the clock is 00, it's going to be negative 90 degrees. Based on this, we can figure out the equation to getting the sun's movement. So the angle of the sun is 0.25 times the time in minutes minus 90. This is our y, it's going to be our y-intercept. So this goes here, this goes here. How we can translate this to code is pretty simple. So let's declare a transform, sun transform over intake. As you can see in our equation, we need the angle, the time in minutes, and these are our constants. Time in minutes. Good thing that we've defined these static functions, so it's easier to convert. Hours to minutes. Now that we've gotten this, we can just set the angle. And finally, now that we've set the angle, we can just move the sun. Assign the directional light like this. Bam. So this is 6 a.m. Now if it's at 12 noon, it's gonna be like that. Right? And now if it's gonna be nighttime, it's gonna be pitch black. So we more or less got this right. Now we can see the full cycle to see if it works by having a way to debug this. So let's go to player controller. This is just for debugging. We'll remove this when we're done. So let's create a debug key, a key that we press that will speed up time. Let's have it our right square bracket key. Whoops. Forgot to make this static. Remember to make this instant static. Now let's test it out. There. See, the sun moves like that. It's time to reflect this on our UI. So how we're going to do this is using the observer pattern. Because we're going to have multiple events and objects that will be affected by time. Like we're going to grow our crops, and the physics of the land, when the player waters the land after a certain amount of time, it's going to dry up. We have various objects at once that will be affected by time. The best way to solve this, so that they don't all each have to check repeatedly at every frame, is to use the observer pattern. So to do this, let's create a new script, time tracker. So this is an interface. And we define the function that will be triggered every time Time Manager does an update. Every object that wants to listen in for any changes in the time state will use this interface, the iTime tracker. Time Manager, open it up. Declare a list of inheritors of the iTime tracker that we will inform through Time Manager. So our Time Manager is going to be our observer class. So every time the time changes, it's going to inform each of our listeners. So let's create So to add, we just have to, since it's a list, listeners.add the listener. And if the object doesn't want to care about the time anymore, we can deregister it. Now, every time there's an update, the time manager is going to inform the listeners by calling the clock update function in the interface. So we can accomplish this with a for each loop. And give it the timestamp. Let's clean up this function a little bit since this is clogging it up. Let's move all this here. Our code looks a lot cleaner. So our first listener is going to be the UI manager, of course, because the UI manager is going to listen in for any time changes and update the status bar over here. So first of all, it's going to need an I tracker. And you see there's an error because we have to implement the clock update callback. So we implement it like this, public void clock update, game timestamp, the timestamp. We have a time and date. But before we do all these callbacks, we have to remember to register to the observer. So we're going to be using the 12-hour clock. So there's an AM and a PM, and then the time here. But the problem is our time manager is using a 24-hour clock because there's going to be 24 hours in a day, and once it's 24, it's going to reset. We're going to have a string called prefix. It's going to be either AM or PM. If hour is above 12, decrease the hour by 12. Right, so 13 becomes 1 p.m. Yeah, and the prefix changes to PM. And finally, we just have to take this, our time text, this prefix. Remember to add a space between, because you see there's a space here. Yeah, prefix plus hours plus minutes. Now remember to assign the time and day to UI manager. Where is it? So the date is date, the time is time. Okay, now that we have set that up, let's playtest it. Now reference. Oh yeah, we have to initialize this. Don't forget to initialize. There. Yep, it's working, but not exactly in the way we want it to. If you better format the minutes. So let's go back to UI manager. See that it's separated by a colon, so we forgot the colon. And the minutes is going to be displayed in double digits. So what we do is minutes.toString, and we want to tell it to display it in double digits, like that. Now the time's in double digits. Huh. Oh, I see the problem. It's just the size. So we just have to make this a bit smaller. Okay, there shouldn't be much of a problem. Okay, now on to the date. We'll get the day and the season, day of the week. It's going to be structured like that. Date text dot text season and then a day. Close brackets like that. And the day of the week. Now we want to try it. Yep, it's working exactly as we want. We don't need a space here. There's a slight second pause before everything updates. This is because we put this at the bottom, so it's gonna wait for 1 second first before everything starts. So you just have to move this to the top. And everything. Let's apply it to our land. So when we see our land here, when the player waters the land, it's going to stay watered for a long time, for forever. So we want to make it that the state reverts back to farmland after a day, after 24 hours. We're going to add the time tracker interface and do the clock update here. First, we're going to declare a timestamp, time water. So we're going to cache this here. So we need to get the timestamp from Time Manager. So let's create a get function to get our timestamp since it's private. But the problem with this is that it doesn't let other objects cache the data because it just passes a reference instead of a variable to keep track of. So what we should do instead, let's go to our game timestamp and create another type of constructor that makes a copy of itself. We can clone this. So that way it will be another reference. So now in our land, when we see the watered status, we just have to add this. Now that we keep the time that it was watered, we have to check if 24 hours has passed. So how do we check if 24 hours had passed? So we need to create a function that calculates that compares two existing timestamps together and gets the difference. So to compare the timestamps, we have to take the difference in hours. First, we convert the years into days, and then we convert the days into hours. It's going to be nested. Same thing, convert seasons to days and days into hours. Take the days and convert it to hours. And finally, add the current number of hours. Yep, it's going to be display in hours, so as to not get confused. Do the exact same thing with timestamp 2. So we're using mathf.abs to make sure the difference is always positive. We don't actually need this parameter. Let's just keep things simple. Okay. So now we're going to compare the time water to the timestamp. Let's check this first. Debug.log. See how many hours elapsed. See if it works. So I'm gonna hold the area. Bam. Oh, we forgot to add to the listeners. This is important. We have to not forget it. That should work. Now when we water it, yep, we can see how the number of hours. Just switch the state back to farmland after 24 hours have passed. And I decide to water this much later. Let's see what happens. Ah, see? It dries up and becomes farmland again. Yep, that's it for this tutorial. Hope you enjoyed it, and we'll see you next time.